Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Triangulation is brought to you by Cashfly at CACHEFLY.com. This is Triangulation, episode 108, recorded June 19th, 2013. Chris Lewicki, Planetary Resources. It's time for Triangulation, the show where we get together with some of the most interesting, smartest people online and get to talk to them, find out what they're up to, get to ask your questions. That's why it's a triangle. It's me, our guest, and you if you're watching live in our chat room. And we've got a great guest for you. I'm very excited. Space scientist Chris Lewicki is on with us. He is the chief engineer and president of a company called Planetary Resources, a company founded by Peter Diamandis, the idea being to mine asteroids. And I want to talk a little bit about that. But they got a lot of attention very recently because of this Kickstarter project, ARKID, a space telescope for everybody. And they are 11 days to go to raise $1 million. They are within $33,000 of their goal. And I'm hoping we can put them over the top during this hour. Let's say hello to Chris Lewicki. Hi, Chris. Thanks for joining us.
Pleasure to be here. Really excited to share what we're doing with everyone and just have a lot of fun discussing the exciting projects we've got going on.
Is that ARKID behind you?
It is. I've got a mechanical prototype of the spacecraft right here. I'll bring it a little closer.
It's pretty small.
It is?
But it's got, I see solar panels on it. It's not as big as Hubble, obviously.
It's not. It packs a lot of power in it that Hubble does not have. But it's also about, let me think, 10,000 times cheaper than Hubble or so. So we're getting to a point in time when small teams of engineers like ours at Planetary Resources can really do these projects and involve the public and do them more frequently than once every decade or so, or even not at all. So being able to do what we're doing in exploring space privately and robotically, and to have the opportunity to get that direct engagement of everyone out there is something that's been very exciting for us, and we're confident, of course, we're going to pass through our goal. We're going on the way to $2 million so we can do fun things like observe and confirm extrasolar system planets and other fun stuff.
Now, when I first saw it, I thought, well, $1 million? You can't do this for $1 million. That's not the total cost?
No, that's not the total cost. We are already building and designing and deploying these telescopes into orbit, whether there was the Kickstarter or not. This actually came out of an idea as we announced the company about a year ago. So many people had expressed interest in either volunteering or sharing their ideas or getting engaged. Thousands of people wanted to invest. We had thousands of job applications. And we kind of took all that input and just considered what we might be able to do. And Kickstarter and things like it were kind of coming of vogue over the past year or so. And we thought it was an excellent way to put out a couple different ideas of how to leverage what the company is already doing. We could create some public engagement, create some opportunities for people to be able to participate in our mission. But we could kind of make sure that by doing that, people would actually be interested and it would be something that would be valuable to them. So we've got 10,900 people who feel that that's the case and nearly $1 million. So this money really offsets the costs of us creating this experience for everyone in the public, allowing them to control our telescope in space and take an observation, creating the educational programs that we'll use to go into classrooms around the world, and doing those fun things like the space selfie or your face in space to just for $25 to be able to kind of put your face out there in the cosmos and have the picture to prove it.
It's a great way to capture people's imagination. Can you show us how that works?
So we have, one of the things I spent about 10 years at the Jet Propulsion Laboratory with NASA. And it was kind of funny because we sent, of course, many spacecraft out into the solar system and the ones on the surface of Mars. And the things that people are most excited about after you see those glorious pictures of a new place in the solar system is seeing that machine that human beings built.
It is.
So one of the first
on the
ideas
planet.
we had.
Yeah.
One of the first ideas we had was after we get our telescope up into space and get it all deployed out, and I'll get a little bit farther back here, was to essentially put up this little camera so that you would be able to get that view down the bore sight of us taking pictures of the universe with this little camera, so you can kind of see our machine out in space. And then we had another idea in terms of if we would make this available for everyone, that this whole area right here is something that you're going to see all the time. And we thought, well, you could put logos and plaques and all kinds of interesting engraving on there. But what if we actually put something dynamic, something that people could put messages? And what hit us when we started this campaign, there you've got the rendering of it, was that people could put pictures. And we actually could take a picture, we could put it into the spacecraft's memory, and then when we get up in space, snap a photo of that. And then you have that picture really like when you travel somewhere, like going to Paris and the Eiffel Tower. You can, of course, buy a picture of the Eiffel Tower. You can go to Google and find pictures of the Eiffel Tower. But yet, we all take the picture ourselves because remember the day that we were there and what it was like and the experience of doing that. So that's the same thing we're doing with our space selfies, is giving the people the opportunity to interact with outer space and to really have that piece of the experience for themselves.
People want to find out more or donate, go to Kickstarter.com and search for ARKYD. Already almost 11,000 people have donated. You're very close right now.
We are very close. We're actually, one of the things, if you scroll down on the page, we've got a number of stretch goals. I already talked about our stretch goal. If we are able to double our campaign, and this is not uncommon in campaigns, in the first half you kind of get half of your pledges, and then the last few days, it's often that people who are waiting on the sidelines decide to take part, to not miss out on the opportunity, or we give them a lot of reasons to go out and stretch to that end goal. So our alien planets goal is something that we can upgrade the stability systems and enable MIT researchers to be able to use our telescope to search for extrasolar system planets. You can see that we've got a kind of a near-term goal there, a little bit past our $1 million goal, where we'll add a second ground station and we'll be able to deliver the images more quickly. And we have a mystery goal, a couple of them actually, that when we get to 11,000 backers, and we're actually almost there, we'll reveal a new goal that I think will be very exciting for everyone and will be something that will be just really fun related to the overall project and still right down the middle of what interests everyone so much already.
Now I have a new goal. I want to get to 11,000 backers before the show's over, so you can tell us what the mystery goal is. ARKYD on Kickstarter. So how does this compare to Hubble? It's a lot smaller. Is it as powerful?
So as you know, you got a big camera lens. You can take pictures of faint objects and stare at things very far away. A telescope's ability to see is a little bit related to its size. We have a 20-centimeter mirror. Hubble has a 200-centimeter mirror, actually about 240 centimeters. So it can take a little bit higher clarity pictures than ours, but of course, you don't get to drive Hubble. But what we do have the advantage of, too, in order of you being able to take control yourselves, we're up above the atmosphere, up above the clouds, the day and night cycle, weather, all those things, so that we have actually a lot better capability to see than the same size telescope would have here on the ground. And we're just really excited to give the capability for you to be able to drive something in space. When is the last time that most people ever had the opportunity to do anything but watch something that happened in space? This is something for them to get directly involved.
Wow, isn't that cool? And now let me ask about the data. Tali in our chat room asked, the data for Hubble eventually becomes public domain. What happens to the data gathered on ARKYD?
So a lot of different things, actually. We have parts of this information that will be shared with the entire world, especially with science centers, museums, universities, classrooms. People who pledge the project really will be part of an exclusive community that gets access to this data stream. So not only will you get the stuff that you've pledged for, your own selfie or your own picture, you'll have the opportunity to see what everyone else in the world is doing. And it's kind of like having a sister city or a pen pal, seeing the other ideas that people come up with on how to use this tool that has now been made available to everyone. There's some of the stuff that people have, they have to, of course, make their data available to the public, and that's for everyone to choose to do. So some of the stuff will be available only to the person that took it. And with the scientific data, for example, we'll be making it available to places like MIT researchers for the exoplanet work, or as part of the crowd engagement for this, we actually want people to choose, to vote where this information goes, who gets to use the time on the telescope, what we can do as a group in terms of imaging things and gathering scientific information. So it's really a democratic way of exploring space.
Really exciting. And let's just check the tote board, as Jerry Lewis was wont to say. We are now up to 10,922 backers. We're getting pretty close to that 11,000.
Yeah, it actually is jumping up quite quickly here. I'm impressed. You have a.
Let's see if we can get to a million, kids. Come on. There's one that I just donated to, and I really like the idea. It's a fairly large donation. I think $1,700. You can have a school be part of this project. Education supporter. I know which school I'm going to nominate for this. So tell me about that. What does the school get?
Well, this actually, out of all the levels, I think is my favorite. Because imagine a classroom of 10th graders in their science class to be able to think about, all right, we have a spacecraft orbiting the Earth, 28,000 miles an hour, and we're going to give you some time on it. What are you going to do with your time on this space telescope? What would you look at? What can we verify from something that was in your textbook? And it's the whole scientific inquiry. There's
exciting.
So much that we're learning as scientists and engineers and technologists of the technology that really makes our world work. And that involves math and engineering and asking difficult questions. So whether it's a 10th grader or a college classroom, or maybe even grade schoolers, there's really opportunities for students of all ages to ask that question, to go through lesson plans that we'll create with some of the best minds on the planet, to learn about how this technology works and how you can use it actually to learn about the universe around us. So we have 20 people who have pledged their support for this level, and many in the levels above that make these available to classrooms. And this can be an experience that really could shape someone's life on what career they choose to follow and how they may choose to engage in a STEM field to really take their talents and their interests and follow them through to creating something even more new and wonderful for the rest of us to experience.
And as you mentioned, Chris is 10 years at JPL. He was a part of the flight director for rover's Spirit and Opportunity, which was so exciting. Surface mission manager for Phoenix. So I think NASA learned a lesson that in order to support space exploration, you have to win the hearts and minds of people who are interested in this stuff. And they of late have done a great job at that. And I could see that there's some of that going on here too. You agree? I mean, this is so inspiring, but it needs support from the public.
Well, yeah, and it has the opportunity really to do so in a way that's never been possible. We are in the middle of the second space race, where it's not governments that are conquering new areas of research or new opportunities. We have private companies with private funding going out and do things that used to take governments to do, 10, 20 years ago. And the opportunity for you to be able to buy your own ticket into space as a space tourist or be able to support exploration and research that you think is important is really what crowdfunding campaigns and Kickstarter is all about.
Yeah.
And people who pledge to our project are not only getting something for themselves, in terms of our various levels and rewards that we have for backers, they're getting the opportunity to follow along in this experience with the company as we develop it and see firsthand how it is that these projects come to life, what it takes over the course of the years leading up to launch, and then that experience that I've been very fortunate to have of having your creation and something that you had a part in making happen and seeing that unfold, in this case, in orbit around the Earth.
Yeah.
So I think that's really exciting, and it's been amazing to get the feedback and the excitement and the support from everyone as we're doing this.
Now, I'm presuming Arcade is not going to be launched by a citizen rocket. You're going to use a governmental rocket or not?
Yes, we will. There's, of course, many companies out there that create rockets going into space, that launch payloads all the time. We are launching what's called a rideshare opportunity, sort of hitchhiking our way to space. Because this spacecraft is so small, it doesn't actually need an entire rocket to get it into space.
Right.
We can literally ride in the extra space when the big rockets are going into space and get to an orbit that will be worthwhile for us. So there's a bunch of opportunities, whether it's here in the U.S. with launch vehicles that NASA or the government uses, or private companies for communications like Elon Musk's SpaceX,
right.
or even some foreign options. The Russians, of course, launch a lot of our payloads and even our astronauts into space, and there are opportunities with Indian companies, French companies. It's what's so exciting is, 50 years ago there were only two superpowers that were doing this. Today there are lots of options.
Yeah, we should mention this is not this Kickstarter project is not a U.S. project. You've got people all over the world donating, and you've got the page translated into many, many languages, including Klingon. Have you received any Klingon contributions?
Well, we have actually, and we're here we go.
Chris, your Klingon is remarkable.
The Chrono subtitles really put it over the top. We had all 5 minutes of our video translated by a member of the Klingon Federation, and it's been a good translation. Haven't had anyone submit corrections to us yet.
You don't want to piss off a Klingon.
Yeah, well, it's the Ferengi I think you really have to watch out for. The Klingons are really all about loyalty. So
I just think the spirit of this, all of this, is so exciting, and I can't wait. Where will the orbit be for our kid?
So because we are launching as a secondary payload, we really will be riding along with wherever the primary ride is going.
So you don't know yet?
Well, no. So it's very likely that we'll be in a polar orbit, something that is like weather satellites use.
Right.
It could be something else. We have a little bit of selection in that. But all of them are really have their advantages and disadvantages for being able to see different astronomical things. The great thing is that you go around the entire Earth every hour and a half, so there'll always be the opportunity to point it at the right spot in the sky that you need several times a day.
Now, Chris, if I get you to 11,000 backers, will you reveal that mystery?
I think that's probably what I'm just getting a call about right now.
Go ahead. You want to take it? Because we're getting close. We're only 59 backers away. If everybody watching in the chat room donates, I want to get to 11,000 backers, and I want to get to $1 million. I want to put it right over the top during the show today. I think this is great. And as I said, I donated $17.50 because I know a classroom that would be great to have this. The classroom gets the curriculum. They get 10 selfies. They get to do some exploration on their own. What a great way to excite people, excite kids about science. So I don't want to take up all the air in the room, so I'm going to let everybody in the chat room. We're up to 10,942 right now. If we reach 11,000, can you reveal?
We will. We've got it all ready to go, but we're not going to do that till we hit 11,000. You have to keep refreshing the page.
So I want to ask a little bit about Planetary Resources' original goal, which is still a goal, which is asteroid mining.
Absolutely.
I'm fascinated by that. That's a science fiction trope, but I think increasingly becoming practical and realistic. Tell me about that.
Fascinated about asteroid mining.
Yeah. Yeah. Well, no, because of all the things that we talk about in space exploration, this one seems not only the most doable, but with the biggest payoff.
Well, absolutely. We don't say it lightly that the first trillionaires will be created by businesses that are in space. This is an economy that it's not global. It's quite literally universal. And why we are pursuing this as a company and why our investors and our founders have set us off in their direction is it's through the exploration of space and through the use of resources in space that we're going to be able to do this sustainably, so that it's not a government activity, so that it's driven by really what everything on this planet has ever been driven by, and that's an economic engine and people trying to compete and create an economic opportunity and a business reason to go out and do that, so that we don't have to ask taxpayers to do these things out in space. So asteroids, as it turns out, are some of the most accessible, most valuable real estate off the surface of the planet. And did you know that there are about 1,700 asteroids that we know of today that are closer, when you consider the rocket power to get to them, than the surface of the moon?
That's a lot. No, I didn't know that.
So the moon, of course, seems like it's very close, but the moon is literally like climbing up a mountain. It's got gravity, and it's gravity that you have to slow down so you don't crash onto the surface. And there's 1,700 asteroids out there that we know of today that are actually closer than landing on the surface of the moon. Now, when you're on the moon, like when I'm on the moon, and I like to go out and pick things up, maybe bring them back. And if you want to make that round trip and come back and bring those materials back to the Earth, that actually is, you have to climb back up out of that mountain. And there's actually about 5,000 asteroids that are closer than making that round trip. And this is because asteroids don't have much gravity. You don't have to slow down, and they're not drawing you in. You don't have to accelerate to get away from them. So that's one of the really exciting things about this. The other thing, let's talk about the resources that are on them. Asteroids have all sorts of interesting things because of where they are from the formation of the solar system. So they have on them things like platinum group metals. And the platinum group metals on the Earth primarily sunk down to the core billions of years ago because the heavy stuff kind of sinks to the bottom, right? But in space, that didn't happen. So we have concentrations in some meteorites that we have found on the Earth that are several hundred times the most productive mines here on Earth. So that, of course, is very attractive of something that you could potentially build an industry off of. But there are two other things that make asteroids very interesting. One is just metal and structural materials like iron, like nickel, like cobalt, the stuff you make steel out of. And in space, a metallic asteroid is a lot like stainless steel. And there's enough material in our solar system, in the main asteroid belt and the near-Earth asteroids, to have 7,000 tons of material that is available for every living person alive today. You could build a skyscraper 7,000 stories tall that would cover the entire surface of the planet.
That's a lot.
That is a lot. So this is the type of stuff that you build Starship Enterprises out of.
Right.
And this is sci-fi, but this is how sci-fi happens. There's an incredible amount of resources out there. But now to bring it all the way back to present day, the most important resource in space that I can point to and I can tell you is going to make all the difference for our species, for humanity exploring the solar system, is water.
Right.
And how important is water to every day of our lives here on Earth?
Right.
We're mostly made of the stuff. We depend on it for our food sources and for growing plants. We use water in industry as a solvent. We don't actually think of often how water is required for anything that we might make, whether it's for microelectronics, all the way out to fabrics or processing ore, for example. So water is very important for that. And when you talk about water in space, water, of course, is extremely plentiful in here on Earth, but it's expensive to transport. And if you think about the cost of taking 1 liter of water, something that would fill a glass, and sending that water to the International Space Station, that'll cost you $10,000 per liter.
Wow.
If you want to send it farther into space, you get to several times more of that, up to $50,000 just for a liter of water. And how many liters of water do you think it takes to fill you up? So getting that material in space is so important. And because it's in space, it has two other unique uses that really separate it from anything else we might do in space. One is, in space, you probably know about radiation and radiation's effects on our cells and our ability to kind of continue living. The Curiosity rover on Mars just revealed that the amount of radiation that we get off of the sun and the solar system and what's called cosmic rays actually is probably the most that any human should experience in their entire life. So to shield you from that radiation, water is really, really effective. Water is as effective as the entire column of the atmosphere as well as the magnetosphere. and a cubic meter of it actually will protect you as every bit as much as the entire Earth does.
How interesting! I had never thought of that.
Yeah, so I mean, if you're going to explore space, future astronauts, whether they're government or private, are going to need lots of water, and it's much better to get it out in space when you talk about lots of it. And then the last thing, and this is really where it all opens up. Imagine driving a car cross country and never being able to stop at a gas station. So how far would you get? You know, most cars somewhere between 200 miles, maybe 500 miles. And imagine if, okay, you could drive your car for 500 miles and then you had to throw it away. How useful would your car be? So water is a molecule formed by hydrogen and oxygen. And hydrogen and oxygen happen to be the most efficient rocket fuel that we have, chemical propulsion, on the planet. It's the same fuel that fueled every space shuttle launch that we've ever sent up. I'm just watching the numbers rise here. We're
almost there. We're gonna get there soon.
I am very impressed.
Before you're done,
I hope our crew is ready to
reveal.
It was going a little bit. Yeah, I don't know if we're quite ready for the reveal yet. But,
we kind of beat you to it. So so how many of those 1,750 asteroids in the asteroid belt are snowballs? Ice balls.
Well, so we know in the main belt, actually, about half the main belt asteroids are. Wow. These are the ones between Mars and Jupiter. And we're actually not quite sure because there's not been enough exploration done on the asteroids near to the Earth. We know it's a pretty good percentage, but we've got to go out and find them. And that's why we're building things like the Arctic Space Telescope. That will allow us to do this. And for people, for example, that are pledging at the $10,000 level, one of the perks at that level, and this is something your readers may know about the oatmeal.
Yeah, he gave 10 grand, didn't he?
He gave 10 grand. He just announced that today. Matthew Inman is a fantastic guy.
Yeah.
He's got some creative names that I don't think will get past the International Astronomical Union.
He wants to name it?
Well, he's offering a chance for his readership, actually, to be able to name the asteroid that we would discover for his slot. And everyone pledging at our 10K level gets the opportunity to do that for the asteroids that we find.
Well, there's one asteroid they can't have. That's 13609 Lewicki.
Correct. That one's already been taken.
Yeah.
I've got my very own asteroid because I happen to have some friends back in college at the University of Arizona, and University of Arizona actually runs the programs that have found over half of the asteroids that we know about in the solar system.
Wow.
So this is something that I'm very privileged to have one named after me. I'm looking forward to finding a few more in the solar system and extending that experience to other folks as well.
I think 20403 Oatmeal is not a bad name for an asteroid, to be honest with you.
Yeah, that could be. Yeah, Oatmeal.
So, so you don't know, or you don't have a goal yet about what kind of asteroid you'd want to harvest?
Oh, no, we do, actually. And I was talking the story about water.
Yeah.
We are looking for carbonaceous asteroids, or carbonaceous chondrites, as they're often called.
Okay.
These asteroids we were talking about are rich in volatile elements like hydrogen, carbon, nitrogen, and oxygen. And then, of course, when you combine those elements, the molecules they create, like water and ammonia and methane, and they're just very useful for a number of different things.
These are the organic chemicals. This is the foundation of all life on the planet.
You've got it exactly correct. And to be able to get that material out in the solar system and use it out there for continuing to support the continued prosperity of humankind, it's very important stuff. So the
idea is not to bring it back to Earth. I mean, if you found an asteroid made of diamonds or gold, maybe you'd want to bring it back to Earth. But this is more valuable where it is.
Actually, it is. It's valuable in space for these volatile resources. We may bring it back near the Earth to create that fuel station so that you don't have to throw away your car after you've driven it to had an empty tank.
You started that story and I interrupted you. So So tell me, finish that. What I don't understand.
When you launch a rocket into space, when it gets to low Earth orbit, most rockets have exhausted all of the fuel that they have.
Right. We let them fall back into the ocean.
and they fall back into the ocean. You throw them away. You use them once. And imagine how much an airliner would cost if you you flew Washington D.C. to Paris and then you threw the plane away
Throw
when
it
you
away.
got.
Yeah, that's so good.
That's why rockets cost so much money. Imagine if there were just a fuel station where you can refuel it. Someone's going to have the opportunity to put us over 11,000 here on this show.
We're very close. Only 11 more backers, and we'll go over that.
I think that we have to get to over 1 million while we're on the show.
I want to do that. I don't know if that's going to happen. You still got 19,000 to go here.
Yeah.
Yeah.
So to be able to refuel when you're up in space is really the ultimate thing, and we'll bring the stuff back close to Earth for these volatile resources. And when we are able to do that, when we can create fuel, when we can have water for supporting human life, we'll be able to really do anything we want. I mean, you can think about how much ingenuity and capability we have in our industrialized countries to just be able to invent all forms of industry, create buildings, make roads, and support our whole quality of life. This is all about extending that out into space and pioneering, quite literally, the next frontier. We're creating the frontier town up there in space.
Wow.
And if you could imagine Lewis and Clark heading off into the Louisiana Purchase at the direction of Jefferson, they stopped in St. Louis before they went out into the Great Wild.
The Gateway Arch, yeah.
And it's the Gateway Arch, and they stocked up. They got all supplies and rations. They sent their final messages, and from there they were able to explore the entire American West frontier. In a lot of ways, this is what, when you get into Earth orbit, that's where you're at in Earth orbit. As Robert Heinlein, a very famous science fiction author, says, you get into low Earth orbit, you're halfway to anywhere in the solar system.
Because that's the gravity well. That's the hard part, is to get out of there. Yeah.
And there's a chart that I have in my public presentations where I show the Earth and the International Space Station and the Moon and Mars as how we usually look at them from a distance standpoint. And you know that all those things are very, very far away from each other. But when you look at it like an aerospace engineer does or a rocket scientist does, and you consider the equations, all those things that are out in space are actually pretty close to each other. It's the Earth that's really far away.
That's such a great way to put it. Yeah.
Yeah.
So you want to build St. Louis would you move this asteroid to a low Earth orbit? Where would you put it?
We would extract the useful resources off of it, and much like you don't bring the crude oil to the gas station, you bring the refined stuff to where it's needed.
Right.
And we would bring that to high Earth orbit, low Earth orbit, around the Moon, on the way to Mars. Essentially, all the way. You could imagine gas stations around the solar system that allow us to be able to travel around and do whatever we want, wherever we want. But the logical place, of course, will be to start near the Earth. And then once we've developed things, we can move out from beyond there.
And
we had like 5 people all pledge it. We're at 10.
Ladies and gentlemen, we are now one away, one more pledge, and we will go to 11,000. There we go, 11,001. So I think we turned that number over. So Mystery 1 will be revealed. You don't have to do it right now, but before you leave.
Yeah, I'll give the team
tell the web team
the opportunity to update the graphic.
But let's keep going, because I don't know if we can hit 1 million, but I'll tell you one thing, Chris. I can promise you
by the end of the show.
Okay, perfect. And I can promise you that the vast majority of the show watches after the fact, doesn't watch live. So we're tapping into the live audience. But once this show goes out, you'll cross 1 million very, very quickly.
Yeah,
that's not going to take any time at all. So
that's something I really want to emphasize. We've been very successful in this campaign. In just the first few days, we were able to get nearly all the way to the goal, 80%, very quickly. And for people who follow crowdfunding and Kickstarter campaigns, you always know that there's that stretch in the middle where people are learning about more details of what you're doing. You're getting a bigger audience. And then in the last week and really the last few days, you often see these things double what they started at.
Sure.
In some cases, especially computer games and things like that, go double, triple, quadruple. And, we've got these stretch goals identified. I don't know if we'll be able to meet the $2 million goal. This is something that is really up to the public. If they want to see us do exploration of alien planets, it's not going to happen by waiting for other people to do it. People are going to have to pledge. And we've, whether it's $1, for just getting in and following this campaign and being able to experience what we do. If it's $25 to get your own space selfie, if you want to do the thing where you can share even at the $99 level to become a member of the Planetary Society. This is the largest private space exploration organization in the world, headed by Bill Nye, the Science Guy.
Oh, that's great.
And originally founded by Carl Sagan.
Oh, great.
So this is something that you can become a member at pledging at the $99 level, and it keeps things are going up there. There's one thing I'll actually, while we're on the air, talk a little bit about our add-ons. Oftentimes, people, we don't assume that everyone's going to want the same things. And if you scroll way down our page past the Klingons and past the museum benefactors, you can see some fun stuff down at the bottom, and this is nearly at the bottom of the page. We've got a lot of limited edition T-shirts that are going to be exclusive to people that are pledging on Kickstarter.
Oh, look at that.
Print things out. And imagine being able to have a greeting card that has your face from space on
I love that one. Yeah. And I like the Dino Revenge T-shirt. That might be the one I'll get there.
Yeah, exactly. Yeah. 65 million years ago, asteroid, of course, knocked out the dinosaur.
Now we're going to get the asteroid back.
Yeah, we don't have to go the same way. We've got technology now, and we can be masters of our own domain.
How realistic and practical is the idea of asteroid harvesting? Is it a distant goal, or is this something we can do in the next decade, let's say?
We're going to make fantastic progress on this in the next decade. And this is why myself and all of the fantastic engineers who have joined our company and have really dedicated their lives to making this happen. These technologies don't get created by sitting by the sidelines and waiting for someone else to do them. They take companies and individuals setting out goals and really turning that science fiction into reality. And we've got a step-by-step program which starts with simple, low-cost, kind of robotic geologists to go out there into the solar system and find the most interesting asteroids, the ones with the water on them, the ones that have more metal on them. And this is stuff we know how to do. We've been exploring asteroids for 10 years with spacecraft. We've been discovering them for hundreds of years. We've been sending spacecraft out into the solar system for 50 years now. And I always like to tell the story of the Ansari X Prize and the company that is now Virgin Galactic, run by Richard Branson and my good friend George Whitesides, who's the CEO. So this was a company that came out of the pursuit of a prize actually that one of our co-founders helped organize with the X Prize. And what they challenged the world to do for a $10 million prize was to take a craft, put a person in it and the ability to carry 3 people, send it to the edge of space and bring it back safely, and do it twice in a short period of time to prove that it wasn't just a stunt. And Burt Rutan, an innovator in aerospace, and his team of a couple dozen engineers for about $25 million, supported by Paul Allen, that small team in 2005 was able to do what it took the entire United States Air Force in 1961 to do with Alan Shepard, and of course what took the entire Soviet Union to do with Yuri Gagarin. And this is something that is possible to do now with private companies, private funding, and current technology. So we absolutely have the technology to go out and explore and identify and prospect, do the first traditional kind of prospecting phases of mining. And if you look at the oil industry, and this is another story I love to tell, it's been fascinating to learn about this stuff. The oil industry 30 years ago did not have the ability to go down to the bottom of the ocean and get oil. We were still getting all of our oil off of the land and maybe just a little bit offshore. But Shell Oil and companies like them in the early 80s started investing several $billion to go and explore these very deep oil platforms and the ability to go through out into the open ocean, to go through a mile of water, down into pressures that are hundreds of times our atmospheric pressure, in salt water, in hurricanes and currents, and then drill down through another 2 miles of the Earth's crust down to that oil vein. And they put billions of dollars into doing this and created technology which I assure you exceeds the technology that we use to land rovers on Mars. And they did this all with private funds, and they did it because with the billions invested, of course, there were tens of billions to be made.
Right.
So when there is money to be made, the capital to solve these problems appears, and the human ingenuity and engineering is brought to task to really make this stuff happen. So it's not an issue of technology. It's really just an issue of identifying and clarifying that opportunity and really showing the world that it can be done. And I'm really happy that Planetary Resources has assembled such a great team to do this. We've got strong supporters, and that along the way, we can do fun things like this campaign of taking the public along with us in this journey that we're going on and to share the experience with everyone out there.
I love that. So water would be one of the things, volatile chemicals and other. Are the trillionaires going to be the guys who are getting the diamonds or the gold, or what do you see the commercial aspects of this?
Well, think about infrastructure and think about U.S. steel at the turn of the last century, and everything that steel enabled in this country expanding and industrializing, making buildings, railroads, automobiles, all of those things, the quality and the comforts of life that we join, and those types of things. It's the infrastructure in space that we're creating, and the fact that we're now not limited by the surface of our planet and the arable land that we have, and where the best property is near the ocean, where the weather is the best. We now have the ability to get into the solar system and really be able to operate without limits.
Right.
And that's the thing to think of, is we're creating a new continent and exploring a new frontier, and it'll be the resources that will be enabling to do that. And it'll be those resources that will be the valuable thing to be able to develop and use as we create all these different industries in space. It's going to be a whole economy, just like anywhere that humans move into. There's all sorts of different things that make it all work.
And a huge opportunity to return to the moon, because if you find an ice ball, you've got the water you need. You get you put the low Earth orbit gas station up. The moon suddenly becomes a pretty nearby place to go.
You're a very, very quick study. So the surface of the moon and being able to use space resources. Imagine now if you could fuel up before you climb that final mountain down to the surface of the moon and drop into that gravity well. So you wouldn't have to, make the trip all the way from the Earth to the moon, or the surface of the Earth to the surface of the moon. You could fuel up along the way and use that fuel from asteroids to be able to go back and forth from the surface of the moon. There's actually, even resources on the surface of the moon that are great for fueling up when you're on the moon, to use that to then leave the moon or to support things that are on there. But, this is all about creating the interstellar highway system of the solar system. And water and the resources of space are going to allow us to do that. And it all starts with projects like the Arcad 100 Space Telescope, of being able to find this stuff and know where we want to lay down that first ground and lay those first railroad ties.
Wow, it's very exciting. We're at the beginning of a exciting new time. Does government, or will governments have a role to play in this, or is it all going to be citizen space?
Well, government already has. What we're doing today would not be possible without the last 50 years of space exploration.
Sure.
We're really standing on the shoulders of a huge investment that the United States has made in aerospace, and internationally, what's been done with projects like the International Space Station. Mm-hmm. And that work continues, of course. NASA has a goal of sending humans to an asteroid by 2025. Planetary Resources is excited about being able to help NASA achieve that goal by providing them information on which targets they should go to, the hazards that might be there, that the asteroids might experience and need to be prepared for before they arrive. And again, the ability of the astronauts to use those resources that are out there to be able to stay longer, to protect themselves against radiation, and really to just be able to start making these outposts, whether it's for humans or for industry. So there is an opportunity for a private and public partnership, much like the railroads or the interstate highway system. The government built the highway system. They didn't build everything that went along the highway system, or what was the places along the way. So this is something that is really a combination of both of those, and it's really it's I can't say it enough. It's the next frontier. I don't even know if it's the final frontier, to quote Star Trek, but it is something that I certainly think that we are living in the most exciting times of the entire history of our species. And even if you go out 1,000 years from now, the things that are going to be written in the history books today are going to be, the first time, men left the planet and landed on another solar system body. Landing on the moon will be a big deal.
And as long ago as that was, it's still in our era. 1969 isn't that long ago.
Yeah.
We're in the beginning of the space era.
We are.
Yeah.
So exciting. Imagine, so we are a global civilization today, and even a couple hundred years ago, we weren't global. There were still corners of the Earth that we hadn't explored and didn't know about. But now you can say, everything's been imaged by satellite, and there's been someone who's been to pretty much every corner of the planet, and there's few surprises left. So we're in the era where space will become commonplace. I look forward to having the opportunity to travel to space myself one day, not as a government astronaut, but as a private traveler, just like anyone who buys a plane ticket might do.
Do you think you'll get out of Earth orbit?
Absolutely.
All right.
I think the most exciting, we've been in the Earth orbit for 50 years. We need to go out to farther, more interesting places.
Yeah.
And being able to see imagine the feeling that the Apollo astronauts had when they could extend their hand out and cover up the entire planet with their thumb.
Yeah.
Being really out on the fringes of space. I think within this next couple of decades, we're going to see humans out to the surface of Mars. And what I don't know, this is a fun subject to talk about. I don't know if the first people that we send to Mars will come back. The first people that we sent to the North American continent probably didn't have any plans of coming back. So
I think you're right.
This is true exploration.
I'd volunteer.
A lot of people have.
I'd go. Even if I couldn't come back, I'd go.
Yeah.
Yeah.
So I'm just watching the numbers tick up. We're actually doing pretty well towards that $1 million goal.
Yeah, we halved the distance, but I don't know if we're going to get to 1 million. I'll tell you what. Why don't you reveal, since we did cross for sure 11,000 backers, your stretch goals, 1.3 million, which we're not there yet, will be for an extra ground station, 2 million for exoplanet exploration. But what is that mystery goal? That $1.5 million mystery goal?
Excellent. So let me just overview all of the goals. So at our $1 million goal, this campaign will be funded.
Very close to that. That'll happen by tomorrow.
That'll happen by hopefully later today. Actually,
I think so. Yeah.
Our company will commit itself to fulfilling all these wonderful pledge levels that we have and taking people along on this experience of exploring the solar system. With our $2 million stretch goal, if we're able to reach that by not this Sunday, but a week from Sunday on June 30th, when we reach that goal, with everyone's help who's watching this program, either on the live stream or recording, we'll work with MIT researchers and add exoplanet detection capability. We've got a goal along the way. We'll probably hit sometime here in the next few days. All this stuff is out in space. I did say, distance does matter in some cases. If you go with your cell phone out into the country, you notice the signal drops off. You go from the LTE network to the 3G to the edge, and your data rate goes down and down and down. So one of the things that people can help us with is getting their selfies and getting their pictures back by helping us boost our downlink signal. So that is one of the goals that we have. So at the $1.5 million level, let me tell you what we're going to be able to do if we're able to reach this stretch goal with everyone we have. This
is the big reveal, ladies and gentlemen. Thanks to you, the Twit Army. We crossed 11,000, and we took about 20,000 off that goal to get to 1 million. I'm excited about that. So what is that $1.5 million stretch goal?
So our best-selling pledge level has, and the one that the most people have been interested in, to the tune of thousands of people, is the space selfie.
Oh, yeah.
This is something you don't need to be an astronomer, you don't need to be an engineer, you don't have to know how to do any math. You just want to have fun and connect with the solar system. And everyone who pledges at the $25 level and above has the opportunity to get a space selfie and upload a picture of their choosing, whether it's themselves, you and a loved one, you and your family, maybe a silly picture of some friends, a place where you grew up, a message that you want to share with the world, or maybe even an advertisement. So we actually don't place any restrictions on it other than just general suitable for public distribution. And There are selfies that are the standard ones, the $25. You can get the high-def ones and get printouts, send it to you for the $65 level. We have 5-packs. And as you know, we're working on a space project here, and a space project that we're about 2 years away from launching these things into space. And for some people, that's a long time to wait. And we've been pleasantly surprised that we've gotten the support that we have, and people who are willing to support this project and go along on this journey.
Yeah, we're talking August 2015 for this.
Yeah, August 2015 is when we anticipate being able to start really playing out these pledges. But here's what we're going to do if we're able to reach our $1.5 million stretch goal, and it involves selfies. So you know how spacecraft are made, right? You have a team of engineers, and they create a spacecraft, and they bring it together, and they start assembling the parts, and they test it. And do you know where spacecraft are typically built?
No.
Well, they're typically built in a very controlled and secure and clean room.
Oh.
You don't want to get the dust on your optics if you can never go up and clean the dust off. So we build them in a clean room. And, you know, much like you put a computer together from the parts and check it all out, we put a spacecraft together from the parts. And there's that moment in time when, you know, the spacecraft first wakes up, and, you know, we run the camera for the first time. So what we're going to do with this $1.5 million stretch goal, if we reach it, is we're going to give everyone who has a space selfie the opportunity to actually take 2. We'll take one space selfie in space orbiting the Earth, with the Earth in the background, with a picture of your choosing. But next year, in 2014, we'll let you take a second one from our clean room as the spacecraft wakes up and take its very first pictures.
Cool.
So this is an opportunity for us to really let people engage in the experience, see the spacecraft come to life, get a picture of yourself in our clean room, maybe with a technician in a background, maybe a calibration chart. Who knows? These things, there's lots of things. You go and visit NASA and you see the technicians down there working. So you'll be able to have your picture taken in our clean room, and you'll be able to see what place you're in line. And you really get an opportunity to practice yourself for that. You know, when you take a few portraits in the photo booth, the first one always kind of lets you get your pose just right and figure out what face you're going to make. So that's what we'll do with our first space selfies from the spacecraft in the clean room.
Now, if you don't donate, if you're not a backer of the Kickstarter, will it be an opportunity to get a selfie, or is that it? It's just going to be the people who back it on Kickstarter.
We haven't decided yet, and you know, I'm not going to make any promise that we're going to do this.
Because you'd have to upload the pictures after the fact.
Yeah, we do. So there's lots of things involved in doing this, and we might sit down and talk about it, but you know, we might not. We want it to be special for everyone who's pledged to it. We want everyone to have this unique experience going through. So if this is something that's interest to you, I encourage you to pledge now.
Yeah. And
get in, because it may not be available after June 30th.
A lot easier to load up that Nexus 7 or whatever that is while it's on Earth and launch it than it is to uplink and upload of pictures after the fact.
You've got it exactly.
Yeah. How fast is the data stream?
So it depends what directions you're going, everything. These are things that are measured in about megabits per second.
Mm-hmm.
We orbit the Earth
fast.
Pretty fast, but you have to keep in mind that it's like turning your modem on and off. So we orbit the Earth every hour and a half, and we have to be in view of a radio and a ground station to downlink this telemetry. And the more ground stations we can build, the more that we'll have in view. And one of the ones in our stretch goal will actually locate this at a site that we'll identify as one of our education supporters, the museums and science centers that are partnering with us. So you'll be able to go to that museum, and we will engage everyone in the audience here and decide where it will end up going, and the other ones that we may be building. But in it actually, when the spacecraft is overhead several hundred miles up, it's traveling 28,000 miles an hour. So for it to go from horizon to horizon actually only takes about 10 minutes.
Wow. So
you have 10 minutes to transmit all your information both up to the spacecraft and back down to the ground to get all this data back and forth. So it is very constrained, and that's part of the reason why when we go out very far away to the asteroids, we're working on technologies like optical communications and using lasers to transmit information to the spacecraft out at the asteroid and to transmit information back from the spacecraft. And we actually use it, and this is some of the things that we'll be doing in our Orchid 100. This optic that we use to take the pictures, we've been doing research with NASA and universities to use the same optic that takes the pictures to be able to send these pulses of light back and forth to do our communication. So it's a dual function capability to where we can use this this one very large part of our spacecraft like a camera. This is all the optic part of it. It's mostly I'm off the screen here. Sorry about that.
That's okay.
Just adjust
tilt. There you go.
There we go.
We have the technology.
So this is, this spacecraft is mostly camera lens, and like any good photographer will tell you, you want the biggest camera lens possible.
Nice big aperture on that thing, yeah.
Yes. So we don't want to, of course, to have to fly 2 or 3 of those because that gets more expensive and more complicated to do. We want to be able to get as much use as possible out of this big aperture, and that's what a lot of our technologies of leveraging these things allow us to do. And this is the fun thing that we're doing at the company as engineers, is thinking outside the box, figuring out new ways of doing things, and being able to innovate, to lower costs, and to make this technology more accessible and to be able to do more with it for things that will enable asteroid mining.
That's so neat. Is it a CMOS or CCD pickup on that camera? What is?
So yeah, there's a focal plane down at the back end. Right here, it's covered up by blankets, and in space.
A lot of sun heat there, yeah.
Yeah, there's a lot of heat, so the blanket exists both to reflect away the radiation and the energy from the sun. It's 1,366 watts per square meter, lots of energy. And you can imagine in the desert what the sun feels like up in space when you don't have any atmosphere at all, very bright. And then when you get on the dark side of the Earth, it's very cold. So in order to maintain the temperatures for the electronics, we actually do simple things like blankets.
Space blankets, neat.
And behind these blankets is really where all of the technology for taking our images happen. And much like a digital SLR, we have a sensor back there, and we're at the stage now where we're making the exact choices of which sensors it'll be. It'll be a 5-megapixel monochromatic sensor, so it'll sense light in one wavelength. And then we will use filter wheels and filters to be able to create those color pictures and actually be able to see aspects of the spectrum coming in from asteroids and solar system targets and astronomy that your eye can't see.
So you'll do non-visible spectrum as well?
Yeah, so this has a pretty wide sensitivity, especially given that it's above the Earth's atmosphere and you don't have the atmosphere absorbing all of that.
Oh, this is so exciting. I'm glad we could put a little more money in the coffer. I don't think we're going to get to $1 million. You're less than $13,000 away, though. No doubt in my mind at all that you will not only reach your basic goal, but you'll reach those stretch goals all the way up to $2 million. And I can't wait. We'll have you back in August 2015 to talk about
very exciting.
This. Yeah, so exciting.
I just want to thank everyone who has pledged so far in this program. Leo, it's been a really fun discussion, and encourage everyone who's watching this on archive. Go to our website, planetaryresources.com. Subscribe to our email list. Follow us on Twitter to keep along with what's going on. Pledge to our campaign, whether it's for your own interests or you want to provide a gift to someone who's special to you, or create a totally unique education opportunity to help spread this technology and inspire the next generation of scientists and engineers.
It's so exciting. Chris Lewicki was flight director for Spirit and Opportunity at JPL, surface mission manager for Phoenix, and now he is president and chief engineer at Planetary Resources. ARKYD, A-R-K-Y-D, is the space telescope for everyone. If you want to go to Kickstarter.com and search for ARKYD, you can help put them over the goal. There's 11 days to go. Chris, it's so exciting. I'm so glad we could get you on. I'm glad we could find out what that mystery stretch goal was. Can't wait to find out what the next one is. And I look forward to August 2015 to the launch. And I know a perfect school that's going to have a great curriculum in the fall of 2015, all about this great space telescope. And good luck with the asteroid mining. I think that's very exciting.
It's an audacious challenge, and we're having a lot of fun pursuing it.
Transformational, though. It's going to change the way change everything. Thank you, Chris.
Thank you.
Take care.
Pleasure to be with you today.
My great pleasure. Chris Lewicki, planetaryresources.com. We do Triangulation every Wednesday, around about 3 o'clock Pacific time, 6 p.m. Eastern Time, 2200 UTC. Do tune in. Watch live. As I said, I get a lot from the chat room, a lot of the information. And boy, this time you live viewers had a great opportunity to put them over 11,000 backers, and that was really fun. But if you don't get to watch live, do watch after the fact, on-demand audio and video, always available at twit.tv/TRI or wherever podcasts are aggregated, iTunes, Xbox, Zoom, places like that. Thanks for joining us. Who's next week? Dr. Kiki joins us as a guest next week. We'll talk to Kirsten Sanford. That's going to be a lot of fun, our very own neuroscientist next week on Triangulation. We'll see you then.